Let me collect. But you were submitting it as early, certainly. No?
7?
Yeah.
7 due today, you said.
Yeah, but a couple of people submitted it earlier.
Yeah,
I did that.
Actually, okay. For the meta-based homework, I think you have right answers, but ideally one would wish to put like screenshots from the stuff. You know how which grades you typically get through homeworks, right? I'll take responsibility of grading this time because we really need to rush in the class material. Again, if your life is complicated and NVIDIA will give you a sign when to wake up and when it will be like general intellectual things. So there will be regular number, about 10 new slides, but it will be like excessive number of recalling from previous things. So this is key for the homework, but I see you got it right. Upper subdiagonal square roots. For lower and creation, upper one for annihilation, right? You got it. For position squared, there will be cross terms for momentum squared cross terms, but if you add them together, there will be only a dagger A and 1/2. So energy operator in the weather operator terms. And the commutation for weather operators is 1 or -1, and for the commutation of weather operator with Hamiltonian, it reproduces weather operator itself. The same weather operator we started with, either A or A dagger times the frequency and Planck constant. Main part of the course is, unless someone will vote for exam. So main part is research projects, and research projects will be here anyway. You can just vote to add exam. And so here are your votes. We time to process. So when we meet today at the lab, I will just split myself on several pieces in time and just sit nearby to set up potentials and make projects going. There will be general. I'll print and bring this into the course. General guidelines, what is expected, how to complete the project, and those are like relatively standard set of numerical experiment, similar to what you did for this homework, with maybe a little more details and a little more evidences. But here I see more verbal text. There will be a printout screens summarizing numbers, type text in Word rather than handwriting. Okay, 2 meetings ago, we thought. So our goal is to predict future. We want to predict how non-equilibrium state in harmonic oscillator, the initial Gaussian wave packet, wiggles forth and back and maybe changes its shape, right? The last thing you saw on the projects that was presented by Isaiah, and you could practice it for the homework. We are to have the course more like solid and have academic background behind it. It would be really great to derive it by pen and paper, which is a big challenge, even for such a simple problem. We invite, employed, introduced, started to use annihilation operators and started to look at eigenstate of annihilation operator, hoping that it will be shortcut that will help to predict how the Gaussian wave packet oscillates. Right now, the connection is not yet seen, but it will be seen very soon. So, acting on annihilation operator, we found that the eigenstate of annihilation operator has recursion relations between expansion coefficients, right? This is not needed, first of all. And if we plug in, if you assume the 0th coefficient, then we can escalate this recursion and get all terms except the 0th one. Then we try to normalize, so we expressed all of the terms in terms of the 0th one, normalized, and obtained the normalization constant, which was the eigenvalue of annihilation operator squared divided by 2. Normalization constant. Here is eigenvalues of annihilation operator in power n divided by square root n factorial, and here are the eigenstates of harmonic oscillator, which are camels with 1, 2, 3, 4 humps. If you look on the probability distribution. Then, this slide is a summary of substantial intellectual activity. Then we practiced our third rule to predict future, assuming that each eigenstate of Hamiltonian does accumulate phase. And accumulation of phase happens the bigger, the higher the number of states, right? According to the value of energy. So, since we do know the energies for each eigenstate, which escalate as number of states times h per omega, plus 1/2 that we can always put in the brackets. What does it mean? It means that for state number n, phase accumulation happens with frequency n times omega. Or if you have, should I repeat it? Accumulation of phase happens e to the power minus 5 over h bar, and here we plug in the energy of state. You can tell that it will be number n, which is the same as here, number of state times omega. And then pH bar T, but pH bar will cancel here and there. So it is number of states times omega. But e to the power I and omega is to the t. Is the same as e to the power I omega t to the power n. Just by the rule of multiplying exponentials. I don't know how to, naturally, right? You don't object this step. Then we used to have eigenvalue of annihilation operator here. But we can combine accumulation factor, phase accumulation factor, and accumulated in a very comfortable form to put eigenvalue and phase accumulation for lowest power together and use this power n as a common thing outside of brackets. I don't remember if I was telling you before, but it is really a great shortcut and simplification. So if we do this trick, we can tell that functional form of the state will be always the same as eigen state of annihilation operator. So something to the power n divided by n factorial multiplied by eigenstate. But right now we redefine this parameter that we put in power n. Instead of static eigenvalue, it becomes a dynamic eigenvalue. It becomes a value that rotates in complex plane. No tricks, no cheating, just plain substitution of things. Some of you, well, if I would hear it for the first time, first thing, I would be exhausted to hear new information as always. Second, I would feel a little irritation and protest because like before, we always were talking about eigenvalues as something rigid, steady, not changing. And here we are telling about eigenvalue which changes in time. It's a little strange, but no one promised that for non-Hermitian operators, eigenvalues will behave well. And annihilation operator is non-Hermitian, so some created things are okay. So the eigenvalues like stay constants if we look for like Hamiltonian, right? And here it is okay. But it is the same functional form, but this parameter is rotating in a complex plane. Same amplitude, but different phase. Please make verbal recordings of what we did. Probably you will do better than I do. We have functional form for eigenstate of annihilation operator, but in case we predict future of the state keeps the same functional form, but the parameter which comes, the parameter of this expansion, which is at the same time eigenvalue of annihilation operator, becomes time independent.
Can you repeat that?
No. I can try to generate this text once again. I do not memorize the words. So we are looking on eigenstate of annihilation operator. We found, due to recursion and normalization, that it has special functional form. Summation with these powers. And now we are trying to predict the future of the state. We plugged in our prescription to predict the future, and we found that even in the far future, functional form of this state will remain the same. The only change that the parameter here will become time dependent.
Okay. I thought you said time independent. So
Well, I apologize. I'm not a good writer. I'm not a good speaker. And some people call it coherence. And some people call the stuff that comes here as an amplitude of coherence state. Normalization, and it is over. We found C naught. Here is what we did in one step. By the way, here it's very quick hand scratching, but it is a really interesting thing. And based on your votes, maybe some of you will touch it in the projects. So how to create Gaussian state in the potential, in the harmonic potential? Where it comes from? There are several harmonic potentials, and there are several physical and chemical ways to create them. But one of them, assume that you have a molecule where your coordinate is elongations or contraction of bond. Okay? And this molecule can be prepared in different electronic states, ground and excited. For each ground and excited, the potentials will be different. But then there is an opportunity to create laser, not continuous, like in our laser pointers, but very short pulse, short in time. And if short laser pulse is resonance to ground to excited transition, and if it is very short, it just promotes the ground state of the oscillator when it is electronically ground state and vibrational in ground state. It promotes it up to different potential energy surface. And then it will, for excited state potential surface, it is always offset from the equilibrium, and then it starts oscillating force and back. I will come to this scenario again and again, just give you some seeds for yes. So, coherent states, our best helpers for quantum oscillations in harmonic oscillator, and we did look on them from the rigorous mathematical definition. We looked on the time aspect in form of expansion over eigenstates, but our human perception likes continuous distribution in space anyway. Mathematically, it's not comfortable, but just for analyzing and making connection to common sense, it would be reasonable from time to time to return to coordinate distribution. And it is the third aspect of looking on coherence. So it is planned for today's meeting. Using the background and intellectual baggage and strength that we have accumulated from previous meetings, we will return back to coordinate space and see how this eigenstate of an equation operator behaves there, how it looks like. And it shouldn't be a big surprise. You remember from the past, from running method code, it should be like Gaussian stuff going forth and back, right? But before it was empirical knowledge based on the numerical experiment. Now we will develop it from first principles, just run. Okay. Starting actual material. Here is the last slide of today's meeting. If the meeting will be successful, if I will match to speed up and complete everything in time. So we will hopefully find wave function of non-equilibrium state of harmonic oscillator, which corresponds to Gaussian wave packet removed from equilibrium position. In some sense, it will correspond to like pendulum where the spring was like a little elongated and then released, but on molecular level. So some initial position differs from equilibrium. Then we will take wave function absolute value squared and find probability distribution. How probability looks as function of time and position. And we will find out that it will look like a Gaussian distribution, this certain width, where the center of this Gaussian distribution will change in time harmonically with frequency of this harmonic oscillator. So it's very, very natural assumption, same thing as one would get from Newtonian mechanics and classical considerations, like oscillating force and back. And shape in today's consideration will not change. So if we arrive to this expression, it will be a big success. So what's the plan? How are we going to do it? We will use our background from what we did before, specifically the main heritage is that eigenvalue of an initiation operator changes in time and accumulates phase. So all of our previous considerations, they are useful by themselves, but this practical conclusion will be used today. So this mu times e to the power minus e omega t. And there's, I was not preparing the slides at once in half an hour. It was like a couple of attempts, and therefore it is too late for me to change, but at different attempts I give to code this eigenvalue with different letters. Today we will rename mu into gamma. I know it's not comfortable, but maybe I will fix it next year. So this gamma is the thing that we considered before. Before it was mu. Psi equals gamma psi. Just use gamma in the same way as before we psi. So before we expressed an initiation operator in terms of Dirac, ket and bra, transitions from higher to lower, from n plus 1 to n, right? What if we plug in definition of an initiation operator in terms of position at momentum? Can you do it? So if we have a curiosity to see how this wave function looks in terms of position, then we need to recall definition of an inhibition operator, which I need to count on you. I cannot brag of too strong memory. So what should be outside of the bracket? It's a superposition of position and momentum, where factors will make it dimensionless, right?
One over 2mw.
You need an H bar.
Oh, I was going to say, I think there's an H bar.
H bar to nominator or denominator?
On bottom.
Right.
Don't put yours on the bottom.
Any corrections?
H bar goes on the bottom.
Let me try it. Any corrections or error proofs? So the how to check if we do not have any records? So let's look only on the quickly look on the first part. So omega bar x. Well, we will waste time, but the way to check is the same as you did in the homework. To double check if making A dagger A will give you times h bar omega will give you total energy. Will give m omega squared x squared over 2. So I'm not 100% sure, but probably you have records to double check. Yes. H plus 2. It was helpful. So we are defining annihilation operator as superposition of position of momentum. We are plugging in the minus I h bar ddx instead of momentum, right? And then we probably can put h bar out of brackets, and then the factor here will become square root h bar over 2 m omega, and the factor in front of x, if we put h bar outside of brackets, it will gain m omega divided by h bar. So if we make the definition of this parameter and it relates to width of the ground state of the harmonic oscillator, then annihilation operator can be set in the way of position and momentum multiplied by either width or 1 over width. By the way, once we already practiced such trick. We practiced it when we first used annihilation operator for deriving ground state of harmonic oscillator. The only thing that on the left we had annihilation operator times unknown function, on the right side we had 0. Right now it will be not 0. But this analogy tells us that ground state of oscillator is also a coherent state with 0 amplitude. So I'm going to use this definition. So it's a little more complicated equation than the one we were solving before, but it is still solvable. So what do we do? So can we divide each side, each term by psi and multiply by delta x? Divide by psi and multiply by dx. Any objections? So right now each term has both independent, well, some terms have both independent variable and independent and unknown function. And it would be comfortable to have either one of them. So if you divide it by psi, here will be only function. If you divide by psi, here will be only coefficient. And if you multiply by dx, then these terms will contain dx, and this will contain only the psi. And one will be able to take integrals. Sigma x dx, right? Because we remove psi, plus sigma dx is cancelled, so we have only d psi divided by psi. And here we do have gamma dx.
Can you just wait 1 second so we can get started?
Catch me if you can, in the sense of errors. No errors? Not yet. I promise I will make, not intentional. Integration, right? So what is integral of x dx?
X squared over 2.
Immediately 4 sigma. What is integral of d psi over psi?
Natural log of psi, or the absolute value of psi.
Okay. Let's put psi over psi naught because when it's the free constant. What is integral of dx? Okay. So what should we do? Probably solve for psi, right? To migrate this x squared to the right, and then take both parts into exponential. Plus psi equals psi e to the power minus x squared over 4 sigma. I've lost 1 sigma. Let me check. Yes, it was 1 sigma in front of logarithm, which if you remove it here, then it should be gamma divided by sigma here, and here will be sigma squared. Right? So we do have wave function corresponding to coherent state, which corresponds to shifted. wave function to the you see it looks like Gaussian shape. It looks like it is centered not at zero but shifted by some parameter proportional to gamma, like the sigma. But we as humans like probability distributions more. Why? Because later on we are going to plug in the our recent finding that gamma of t is gamma times 0 times e minus pi omega t. And then if this there will be imaginary time-dependent factor, this wave function will be somewhat complicated to analyze. You are already very experienced and strong in analyzing wave function. I have a assurance, I have evidence that everyone, there is a problem that absolutely everyone answered correctly, is plotting and analyzing real and imaginary part of the wave function and telling what does it mean. So each wave function has real and imaginary part. If it has non-zero momentum, there are fringes. The higher the momentum, the denser the fringes. Yes, you know, but it is a little quicker and easier to look on probability distribution that doesn't have these fringes, right? Just for, and it will be easier to explain it to a stranger in a store. Catch a stranger and I want to teach you how harmonic oscillator behaves. So we are going to take psi star psi of this wave function and look how it will what will be the result. It is just the same stuff for the R better. So for right now, I'm going to introduce a trick that I borrowed from the book. Maybe next time I will bring just copies of this paragraph or page. So right now we do not know what was the normalization. We do not know what was the initial phase. And therefore one can allow this postpone fixing of this arbitrarity to the future, which can be done by assuming that in our exponential thing there is a initial phase that will not change over time, but it is a phase where we start from. Why does one need it? This is needed in case we want to be more general and consider elongation to the left or to the right of equilibrium, or not elongating at all, but assigning initial momentum. So if one introduces this parameter, one will be more general. Another thing, when we will be practicing the wave function conjugated times wave function without conjugation, we will need to conjugate all variables that enter into definition of wave function, including this parameter gamma. So if it is real, then we change nothing. But if it is complex, if we know that it is complex through this accumulation of phase, we will need to flip sign in front of this phase accumulation. So if we are practicing probability distribution, when I offered this material for the first time, everything was convenient, and as from year to year, I'm trying to add more and more calligraphic things, but this was not covered here. So if we are looking on wave function and wave function conjugated, then the fact sigma is real, so it doesn't change, but the gamma in front of first power of position experiences this star, which means flip the sign in front of imaginary unit. What is the plan? When we will multiply these two exponentials, it means we will set up a product of their powers. But for better analysis, we will try to identify full square. So here we do have 1/4 of 1/4 sigma squared by x squared. If we add them together, we have 2 instead of 4 because they have been added together. When we take contributions from the power in front of linear position, we add together the amplitude of coherent state with and without conjugation. There is a hope that if we plug in the values for this gamma with and without conjugation, the practicing of Euler function will help us to get rid of exponentials and get just 3 trigonometric functions. It's not for a game. I assume to direct everything, otherwise it will be boring, but we have about 2 minutes. So if we add them together, and if we define everything, of course, should be simple. Just to quickly write this derivation, we can redefine everything in the power of this exponential, except imaginary unit as letter theta. And then adding together this amplitude gamma and gamma star will be adding together 2 imaginary exponentials with opposite powers. And the theta was initial phase minus omega. So we do have this x square with sigma square and 1/2 is taken out of brackets. We do have the 2 gamma naught cosine rho minus omega t accumulation phase, and it will be really nice to have a complete square for better analysis. And we can always add and subtract any parameter, right? There is nothing wrong by adding and subtracting an arbitrary value on one hand. But on the other hand, we do want to identify a full square. So if we call this one as a square and this as 2ab, then b will be everything except x over sigma. This is 2, this is a, and then this combination will be b. So we may redefine new variable as 2 times initial amplitude times cosine of accumulation phase. And then this part, except this minus b, will complete into a minus b squared. And this term will come into definition of the normalization. So full square, b squared here, times the factor that comes into normalization. Those of you who all of you completed last homework 8 have seen that the width changes to time. So if initial width is not ideal, this term, the part of normalization that we put here, is responsible for change of this oscillation. But if we look onto functional form of this expression, we can call this initial amplitude times width parameter times cosine as the average center of distribution, and the rest of the thing is easily analyzed as Gaussian distribution. So we are arriving to the expression that was introduced at the very beginning of the meeting. So if we have non-equilibrium state of harmonic oscillator in coordinate representation, against state of integration operator, it will be Gaussian shape that will shift with time, shift its center in time according to this cosine oscillations with frequency of this oscillator. Try to record it by your own words. Request me to tell it once again if it is not clear. And I hope very much that it will be last slide. Yes. Done. I'll stay here to answer any questions, and looking forward to see you tonight at 5 p.m. QBV 130.
Can you go back to that last slide?
Yes.
Oh.
Forums.
Here is the last slide.
I'm noticing an error.
The E of oil.
Huh?
I'm noticing an error on that last.
You do?
No.
No.
Oh, you want to
It's
see an
fatty
error?
acid, right?
No, it's just the
Yeah.
beginning of the lecture.
But you multiply it by 1.04 and count it.
Oh,
There's no
That's
glycerol.
for the oil link. So yes, you multiply by 1.04 for the oil.
Just the oil link?
Just the oil.
But there's no glycerol, so you don't do the E
You don't
of
have to
oil.
do the E sodium.
Okay.
Watch out on the last one because EB is greater than